All right, guys, here's a multiple force problem. We have a sled. This is, again, a bird's eye view, so we're looking down at the sled. We've got north, south, east, west. The sled is accelerating perfectly east, okay? And it's being pulled by two different strings or whatever. The first one is 150 newtons, 40 degrees north of east, and the other one is 20 degrees south of east, and we don't know the strength of that one. Again, however, we do know that the acceleration is due east. Now, in a multiple forces problem, or anytime you've got these kind of vectors going different, we got to split into the components. Okay, so in this case, we're going to go north-south component and the east-west component. So, for our north-south component, okay, first thing we know is the acceleration equals 0. Now, if the acceleration in that direction equals 0, what does the net force equal? Well, F net equals ma, so it's also going to equal 0. Now, we also know that F net is equal to all the north and south forces. So it's also equal to F1 sine of 40 minus F2 sine of 20. Okay, that simply follows because those are the two north-south forces, right? Now, we can do the same thing east-west. Okay, the acceleration is not 0. We're trying to find that out here. Then, the acceleration is not 0. Oh my gosh, I forgot to tell you what we're looking for. We're looking for the force of F2 that allows it to just go horizontal, and what the ultimate acceleration at east is going to be. Sorry, so we don't know the acceleration, which means we don't know F net, except that, of course, it's equal to mass times acceleration. Okay. However, we do know that F net east-west is also equal to the east and west components. So we have F1 cosine of 40 plus F2 cosine of 20. All right, so we can't solve anything from this. There's two unknowns. We don't know F net east and west. We don't know F2. But in this case, we do know F net north-south, so we can plug in 0 for that and solve this out. So F1 sine 40, if I can find it on here, is 96.4. And minus F2 sine 20. Turns out that F2, if we solve this, is equal to 281.9. Okay? Now we can take this and plug it in over here. And we get F net is equal to 150 cosine of 40 plus 281.9 times cosine of 20. And again, they're plus because they're both going in the same direction on this part. Okay? And so we get that F net is equal to 379.8. We then take acceleration is equal to F net over mass, and we would get 4.75. And that would be how you do it. Again, we split into the components, the north-south and the east-west component. And the reason we do north-south and east-west is we know the acceleration in north-south is 0. So by doing that, we can get another variable that we didn't know beforehand. All right, and that is a multiple forces problem.